Hello and welcome. This is Professor Thayer here talking to you today about functions in lecture 3. So let me go ahead and share my screen and we can go ahead and get started with that. So here we go. So last time we've been talking about variables, functions, and programs. And this time we are going to talk about setting the display. Oh, and there's our assistant, Mr. Max, in the background supervising to make sure I'm doing a good job. All right, so today our topics are functions, nuts and bolts. How do you actually make a function? What's the purpose of doing this? How do we define one? We'll talk about global and local variables, the return statement, and the flow. That is how your program progresses from start to finish. So thus far, we talked about top to bottom. With flow control, we can now change the order that things are going to be executed in. We'll talk about functions, advanced concepts. So we'll talk about composition, how to do the call execution, how to write your call graphs, how to do specifications and signatures, and effects of function execution. Finally, we'll round this out with some Python built-in functions. As promised, we'll finish off with some functions that we've seen before. So I mentioned print is in fact actually a function, so we'll see how that is true. We'll also revisit type, we'll see input, and we will talk about the coercion functions and introduce the math module, which contains many Python built-in functions useful for, you guessed it, doing math. So nuts and bolts, what is a function? A function is a block of organized reusable code that performs a single action. And so we should consider what are the benefits of using functions to write programs, because thus far we've been writing programs and we had no functions. In fact, some of the older programming languages did not really have this concept of functions being in them. And so the question is, well, do we really need functions? Well, the answer is no, but we're still going to learn about them, and let me tell you why. Functions are incredibly useful for organizing code into reusable parts. So imagine that you needed to do the same thing over and over again. Maybe you needed to sum some numbers. And so we had a function called plus. And so wouldn't it be a pain if we had to rewrite the code to do plussing every single time we needed to add stuff together? Wouldn't it be a better idea to have a sort of like a piece of code that was maybe like off to the side, let's think about, and then when you needed to plus things together, when you needed to add, we could call that function and then it would do the summation and it would get the answer and it would send that back. That's kind of the idea behind functions. And so this has a number of useful features in that if you need to revise that code, then you don't need to revise it in every single place that you wrote it. It'll just be one place, and that's the only place you need to revise it. If there's a bug in the code, we know that it's only in one place and it wasn't a copy error or so forth. It makes writing your overall program much easier, because then you can instead focus on the big picture rather than getting lost in all of the individual lines of code. As you start to write your final project, which may be on the order of 100 to 200 lines of code, this will start to become apparent because it's easy to get lost in the code. And so if you can have it modularized and you know that that part of the code is working, that will just be one function call line, and the function will be elsewhere in your program, and it can make writing your code much easier. And you can also then focus on particular areas of interest as you do the development. It also really helps a lot in collaborating with others and in writing code that different programs are going to use. So some of the ways that this might come in useful is suppose you're in the workforce and you've decided to become a professional programmer. Right? It's very rare that you would be asked to write a program from scratch, start to finish, just by yourself. It's much more likely that you would be asked to, say, contribute part of code. And so what you'll need to do is have some main code that will call out to the different parts that different people are developing, and then they would all come back together. So if you can each work on developing modules of the code, then that is going to be far more efficient. It will also help with the organization of that code so that you can put those pieces together to make the overall program. And so these are some of the reasons why we start to think about modular code. So code can be modularized in more ways than simply just functions. And as we start to get into object-oriented programming, that will hopefully start to become increasingly apparent. But to start off with, we just want to put in this idea about modularizing your code, making it into these different modules that are standalone that can then be linked up to the rest of your code to build a larger structure that is the overall code. So that's what a function is, and that's why we use it, even though it's strictly speaking not necessary. So just to give you a glimpse of what a function is going to look like, this is a very simple greeter function. So the name of this function is greet, and it's going to take the name, and it is going to say hello to that person. So this is an example of setting up a variable to be equal to a name, so that's me. And here we're calling our function, which will then send up the name, and it will greet me, and then it will come back to where the function was called. So that's a simple overview of how a very basic function will work. Why are functions useful? So we have talked about this just now, to modularize the code, to organize your code, and then of course to share your code beyond the program in which it is written, because when you write your code in modular ways, it's actually possible to import those modules into other code. So we don't really have time to do that so much. We're generally going to focus on writing a single program per assignment. However, we will experience bringing other people's code into your code when we work with the math module. So we'll import that, and we will in fact be using Python's code that has been written by others. And it's also possible for you to share your code with other people as well. And we'll talk about that in our very last lecture, Your Future in Computer Science. So then let's take a look at the nuts and bolts of how you would actually define a function. What is the syntax and so forth. So what you're going to do is you're going to need to have your header line. So the header line is going to have a couple of different parts. The header is going to have the def. So this is going to be the part that is the keyword that is going to signal the beginning of the function definition. Then you're going to have the my function name. So this is going to need to follow the same rules that the variables will take in terms of what's allowed. It can't start with a number. You can only have the special character underscore, and no other special characters are recognized. And the capitalization is fine to do whatever you want in terms of capitalizing, but if you capitalize differently, it will be recognized as a different variable. Then the next part in the function line is the input. So this is offset by the parentheses. You always need to have them whether or not there is in fact any input. So some functions may actually not take any input at all. This takes two input parameters called x and y, and those are indicated by these variables here. These are in fact variables that are part of the function, and they are assigned values when the function is called. Finally, the definition line is ended using this colon, signaling that now we're going to go into the second part of the function, which is the body of the function. Now, the body of the function is going to consist of any sequence of statements, whatever Python code you need to put there. It is indented with respect to the header. So notice that that is indented here relative to the definition line. That is essential in Python. It is not optional. Finally, it must at least contain a return statement. So here we have our return statement explicitly stated here, and this is what is going to send back or calculate or send out the answer of x plus y. We'll talk in quite a bit more detail about the return statement because there is some nuances about how return works. But we must understand that all functions must have a return statement associated with them, because that's what says, okay, the function ends and now it's time to go back to the place that the function was called from, which is up calling functions. So just because you have a function defined does not mean that the function will actually execute. You must literally call the function in order for it to actually run. In Python, a function or procedure subroutine is like a program within a program. To call or invoke the function, you have to have a function call, and this is what the function call looks like. We have the function name. Again, note that we do not literally type the angle brackets. We type the whatever your function name is. And then we use the parentheses, and we fill the parentheses with the arguments, whatever they may be, including empty parentheses if it doesn't take any input. Now the arguments are put in here, and the arguments are matched to the parameters in the function. So there needs to be the same number of arguments as there are in the definition of the function line. So here is how we call the function. So it's going to run some code, potentially causing effects like a statement, but it also returns a value like an expression. So here is our function call, the one that we've previewed before. So here is the actual call. This is the greet function, and it says greet here because that's the name of the function that was given here. And then we need to have the parentheses to include the arguments. So the arguments that are used are going to need to match the arguments that are defined in the definition line. Now, an important point to note is that what exactly is written here for the variable does not need to be exactly the same as this variable here. It is not actually name that gets passed. It is actually the value that's associated with this, because this is a variable. This variable will take the value of an expression, which happens to be string Professor Thayer. So when this is sent, it will send up the value Professor Thayer, which it gets from the variable name, and it will send that up to def greet. And here, what will happen is a local variable assignment will occur. That means that this name will be assigned to whatever value is sent up. And that is how the local variable name inside of this function will take on the appropriate value, and then it will print hello in the name, and then it will come back to the place that called it, which is right here. So I mentioned local variables, and I haven't really defined those yet. The local versus the global variables is an important distinction to understand. Local variables are the variables that are inside of a function. Global variables are the variables that are defined that are not contained within a function. So the local variables of a function are its parameters and any variables that are defined within the function itself. Those variables are going to have scope inside the function only. What this means is that the values of them will exist only while the function is actually running. Once the function terminates, those values will be deleted from the variable table, and then they will no longer exist. So when we talk about a local variable, we are referring to those variables that are inside of the function. By definition, the local variables include any of the parameters that are defined as part of the function. Then if anything additional is defined inside the function, those would also be included. So the local variables are going to then act like scratch paper for a function. When the function is over, they disappear. And so we think about that as maybe a useful thing, but that may not be totally intuitive as you're getting started. So let me just explain it like this. Suppose I have my handy calculator here, and I calculated up 2 plus 2. And I say, oh yes, that's 4. Okay. Now, so the input to my function was 2 and 2, right? And so what if my calculator remembered the input the next time I want to do my next calculation? So now I want to do 3 plus 5, okay? And so if it remembered the values from before, do you see, like, I don't want those to interfere with my calculation of 3 plus 5. I want to have new input. So you see, in order to reuse the plus on my calculator, I have to delete out the information that was stored in the calculator the last time. So once I press the equal sign, it displays the answer, and that's the end, right? It says your answer for 2 plus 2 is 4. And next question, please, right? And so it's the same thing when we use functions in Python. We want to have the inputs be independent of what happened the last time we ran the function. So that's why we have this idea of scope and local variables, because that is what allows us to carry through the meaning of reusing that code, because it truly can be used to do a new problem without any information about whether it's been used before or not. And that's again why we call it sort of like scratch paper or functions, because we think about it having those numbers in there as it's actually calculating it. But once it gets the answer, it throws away the information it used to get that. And so that is the essence of the concept of the local and global variables and the scope of the variables. So here's another short little function to take a look at. Here is def double. So this function is going to double a particular number. So this is our parameter. So number is a local variable. We also have result being a local variable, which is not a parameter. And that is going to do number plus number to, in fact, double the number. And then it will return the result. And that is how the answer is sent back out. So the parameter number is a local variable, and the variable result is also a local variable. It's just that result is not also a parameter. So number is both a parameter and a local variable, neither of which exists once the program ends. And this calls our attention to this return statement, which is sending that value out. So it's not, in fact, actually remembering what result equals. What it is doing is it is returning the value associated with result. And it will be necessary to capture that information out in the main program if we wish to actually use it for something. And so we should do that, because otherwise, why run the function if you don't need the answer, right? So you should run the function and get an answer and somehow send the answer out and capture it. That's typically what we want to do with functions. In contrast, we have global variables, and those are the variables defined outside of any function. They may be looked up, but not assigned from within a function. That is a mostly true statement. There is, in fact, actually a way to do the assignment from within a function, but we are opting not to work with that in this class because it complicates the situation considerably. So that's why there's an asterisk there. If you need to do this in your final project, we can talk about that at a later time, but we are not assigning global variables, and that is the default behavior of Python. So to try to assign a global variable from within a function, instead creates a local variable with the same name. Local variables shadow the global variables with the same name. So let's take a look at this little snippet of code and try to understand what we've just been saying here. So this is out in main. This is not inside any function, and we have a variable called x, which we assign the value of 3. So this says a global variable named x has the value of 3. Now here we define some function f, which has no inputs. And here we have another variable called x, which is equal to 4. Okay, so the question is x equal to 3 or is x equal to 4? Or did it just overwrite it, or what happened here? The answer is there are in fact 2 x's, which is very confusing. This is the global x, which is out in main. And out in main, the value of x is equal to 3. This is inside the function, and inside the function, there's a temporary variable called x, which has the value of 4. This is an example of shadowing because we have 2 variables, one which happen to have the same name, and that is what causes them to be the shadow, because this one inside the function looks like it might be the same variable as that one, but actually it's a distinct one. So now what we can do is we can print inside f x equals, and then it's going to convert that into a string and print it out. So what do you think it will print? Will it print x equals 3, the global variable's value, or do you think it will print x equals 4 because the local variable's value is 4? In fact, it will actually print 4 because the local value will always trump the global value. So that means they have precedence. And so the one which takes the higher priority is the one that is the local variable while it's active. Now, when we go back out into main, that value, the local variable will disappear. And so it will print the value of the local variable. So global variables should be used sparingly. When the function depends on a value, it should generally be passed in as an argument. Global variables are for program-wide parameters. It would be tedious to pass to all functions. Examples of things that work well As global variables are, for example, running totals, complete scores for a game, that kind of a thing. Most other things you should be handling as local variables inside of a function. So let's just take another look at this. The global variable passed to a function's local variable does not need to have the same name. And so this is because of what we've just been talking about. So let's compare and contrast these two situations. Here we're back to our greet function. So we have, again, my name being assigned to the variable name, and here is our function call where the value that's currently assigned to name is sent up as the parameter. Well, it's sent up as the argument, which will become the input parameter. So the argument here is name. So here's our function, and the function has an argument called name. And we call the function, and as part of calling the function, the value of the argument is assigned to the local variable here, which is called name. So then we're going to print hello, and then we're going to return back to here. Now, do we have an example of shadowing here? The answer is yes, because we have a global variable called name, and we also have a local variable called name as well, which so happens to also be the input parameter for greet. So here we have shadowing where both names happen to have the same name of the variable called name, and also the value of name will be equal. Here we have another example, and so what we've done is we've changed name to X in this version of greet. And so we say, okay, well, is this going to work? So oftentimes students say, no, this is not going to work because this variable is different than that one, okay? But if we think about how Python actually executes this, we can see that, in fact, actually, this is not a problem at all. Here we're going to have a global variable called name and a local variable called X, and there's no problem. There's also no shadowing here. The reason why there's no problem is because step through what's going to happen. Again, algorithmic thinking and doing things step by step. Greet has a parameter called name, and that name has the value of Professor Thayer. So the value of Professor Thayer is sent up, which is the same as over here. Right? The value is always what's sent. It's not actually the variable. So what will happen here is we have a local variable X, which will take on the value of what was sent up, which is Professor Thayer, which is the same thing that name took on. This is an example of shadowing because we have the variable name existing in both places, but in this case, it's called X. But X taking on the value that is sent up versus the local variable shadowing the global variable, there's no problem here. So X will then take on the value that's sent up, that's there, and it will run exactly the same. So in both cases, the output will be exactly the same, and had you not actually looked at the code, you wouldn't even know that there's any difference between them. This brings us to return statements, which we also need to talk about in greater detail. So the return statements exist in every function. It's just that they're not always explicitly written. So what we can see here is that a return statement is going to abort the execution of statements within the function body. So because of that, they're typically found at the bottom, although there are some cases when that would not be the situation. The value of the expression following the keyword return is going to be returned to the function's caller. That is the line that actually called the function. So we get to put something that it sends back. If return is not followed by an expression, then none is assumed. That means it doesn't actually return anything. So a function could execute, like the greeter function, for example. What does the greeter function need to send back? It's just printing to the screen. It does not need to send information back to the caller. So that's an example where none is going to be returned. The function, if the function body ends without a return statement, the return none is going to be assumed. So even if you don't explicitly put it there, Python will put an implicit return there for you. That brings us to none and none type, which is always a little bit confusing. We've been mentioning that we would encounter new types throughout the course, and this is an example of one of them. So there is a type in Python, just like int, float, and so forth, And that type is called none type. Well, what's none type? Well, it's the type that has no value allowed. Well, that's kind of strange. What is that? The value is just none. It means there's no information. It cannot have any other value. The value is simply, there is no information. It's called none. So when we return and there's nothing there, we are returning none, which is the value of none, and the type of that is none type. So the none value provides no information, so Python interactive interpreter simply doesn't print anything, and that's why we haven't been seeing it. So let's just take a look at how the flow of calling a function actually works. So consider these two ways of writing a program. On the left-hand side, we have a linear greeter. So before today, this is probably what you would have done if I had asked you to write a program that's going to greet a user. So you probably would have had a variable equals and then the name, and then you would print hello and the person's name. So this program begins at the top and works its way to the bottom. It passes through a variety of comments, which it does nothing about, and then it does this variable assignment and it does the printing. So when we run this program, the output says, hello, Professor Thayer. Now let's consider the function version of this same setup. So here we would have the greet function, and here we define the greet, a name, and so forth, just like we've seen in the previous examples. So this one is going to run from top to bottom, just like the other one, ignoring the comments. And the first thing it will do is it will load into it the way in which greeting should be done. That is, it reads the function and it now knows how to do a greet. It doesn't mean that it actually does the greet yet. Of course, functions don't actually execute until they encounter a function call. So now I come down here and say, okay, so I know how to greet now, but I'm not going to greet yet. And then it says, okay, variable equals, so we have the name variable equals Professor Thayer. And now we have a function call. So this now is going to call the greet function and it's going to send up the argument name, and name has the value of Professor Thayer. So in fact, what is sent is the value Professor Thayer, and the execution goes over to here, to the definition line. So now in the definition line, what will happen is the value of the parameters is going to be, the value of the arguments is going to be assigned to the parameters. So we have one value, which is Professor Thayer, which is assigned to the input parameter name. And now this is going to print hello and Professor Thayer. And then the controller is going to move from the return statement back to this statement here, and that's the end of the program. So we see that the output is exactly the same, but that the execution order is quite distinct. In the left-hand side, it's simply just linear, and in the right-hand side, the execution is really quite more convoluted to move through the body of the function. It's important to understand that there are some differences between returning and printing a value. When you print something, that means that it makes a textual representation which it displays on the screen. That is distinct from returning a value, which then gets sent out to whatever started the program. Now, what can be extremely confusing about this is that if you're using the Python interactive interpreter, that they may appear to be similar. So when, for example, we run a function in the interactive interpreter, whatever gets returned is going to be displayed on the screen unless none is returned, in which case it doesn't display anything. So if you do 2 + 2 and you press enter, 4 will be displayed on the screen. If you run the greeter function, something will be printed, but the function will return none, and so it doesn't actually print anything. So you may get confused because you saw the same greeting on the screen, right? And so you may think, well, it returned it or it printed it, and it's difficult to understand the difference between the two. So let's try to understand the difference. So when you have a print statement, that means you're asking Python literally to make a textual representation and to display that textual representation on the screen. That's different from if something is returned by the function which is sent back to Python. Now in the interactive mode, it will be displayed on the screen, but if you're running it in a script, which is what we're going to do most of the time, returning something will send it back, but nothing will happen. And so what we need to do is we need to capture it in something, and then we need to actually ask Python to display it using the print statement. So it's kind of like a baseball, okay? Well, I have an orange in my hand right now, so we'll pretend this is the baseball. But it's useful to think about this in terms of throwing some information out and receiving that information. Okay, so suppose I'm a pitcher. Okay, so I'm like the function call, and I'm gonna send this information out to the catcher. Now, if I want to send some information in the function call, maybe I will take a marker, and maybe I will write a secret message on here. So I write some info. The input is, this is not toxic. I want to eat this orange. All right, so I'm gonna put 5 on here. All right, there's my input. So if I take that and because I don't want the opponents to know, right? I'm gonna put it on here, and I'm gonna take it, and I'm gonna pitch that out, throw that out, and the catcher's gonna catch it. Okay, and then the catcher could get that information. So that's like doing a function call with some information that gets exchanged. So we've already talked about that. Now, suppose the catcher receives this information and says, oh, okay, now I know what I need to do for the play. Now, I'm not that good at sports, so you kind of have to bear with me on this if it's not matching the sports, but hopefully you'll get the idea about the ball getting tossed back and forth and the information. All right, so the catcher catches the ball and says, oh, 5 is the input. Now I know what's going to happen next in the game. And so he says, okay, I'm going to need to send back some information to you. So now the catcher's going to get another marker. And that one's their marker. And it's a nice blue one with butterflies on it. Okay, and then it says, okay, now I can do your computation and figure out what's going to happen next. So it's crosses off this one and puts 15 is the new answer. Okay, so now the catcher can send that information back. Okay, so it takes it and it throws it back, and the other guy catches it and says, ah, yes, I got my information. So the idea is that the return is like writing down the answer on that point of control. So this orange or that baseball is representing the point of control in the program, which is allowing information to be passed back and forth, okay? So that's why we have this idea about having that information to send it back. So when we have return, that is how the information is actually sent back to the other player. Okay? So printing would be like just taking it and showing it publicly, okay? But that would not necessarily, but we want to send the information back so that the original player can use that information to actually do something with it. And so that's why we have to have that information and have that actually sent back. So when we have return statement and then the information after it, that information goes back on this point of control. So in order for information to be passed into and out of a function, a couple of things need to occur. So in order to pass the information in, we've already talked about sending it out using the argument in the function call, and then it will be assigned to the input parameters. However, we need to just pay close attention, once again, to that return statement. So when we have the return statement, if there's nothing at the end, it still goes back. It's like this, but there's nothing written on it, right? So none is returned and there's no information given to the other player. Okay, but in the situation where we're actually returning information, then we need to have return and we need to have the expression for that information. So the expression equals 15, for example, okay, and send it back. So what we want to do then is we then want to, we need to catch that information. So if the pitcher throws it out to the catcher and the catcher throws it back, right? I mean, if nobody is there to catch that information, right, the ball just goes out of play. So it's like you have to send that information and you also have to capture it. And so what we mean by that is we need to have a variable there. So that's one of the things we'll be talking about, is to have the function call and then have that variable that's in fact actually going to capture that information as it comes back. Okay, so that's the thing we want to be attuned to as we think about making the function call and getting some information sent back into it. All right, so here we're just talking about printing versus returning, right? So in printing, there's no throwing of the point of control, right? It's only just displaying. It's in returning that it's really powerful, that actually information is sent back. Okay, so let's compare these two functions here. So we have our double function. So in this case, this is going to return n plus n, to return that answer back to the point of control. So we could in fact actually capture that information and use it in, say, the next question. Whereas here we have print double, and all that it does is it prints that information. So the answer will be the same. However, here it gets returned, but in this case, it only just gets displayed on the screen, but it's not actually captured. So like if you needed to get the double and then you needed to multiply it by, I don't know, the dollars, amount of dollars for a double of n, okay, to calculate the total cost or whatever it might be, you would actually need that information. And so that is the difference. We can also do function composition. And so instead of storing a value returned by a function in a variable, it can instead be used directly in an argument to another function. And so this is the idea behind function composition. You, in fact, are probably quite familiar with this from math, but you probably just didn't know it. So let's consider if you are going to do something that has more than one step. So if you do 1 plus 2 times 3, you know that first you'll do 2 times 3 and get the answer from that, and then do the 1 plus part. So that is an example of composition, because you took the answer from one part and you used it in the next thing. And so that's basically what composition is all about. And it removes the need to store the interim value in a variable. So sometimes this is appropriate to do if you do not need to use that value in any other way. Maybe you just only need it for that computation and that's it. So in that situation, composing would be very appropriate. So here is an example where we have no composition. So do you see we have y equals double of 5. Here's our double function, and it's going to multiply 2 times x and return that value. So if we send up 5, then double of 5 will be 10. So 10 gets stored in the variable y, and then we print y, which will print 10. Now we could have done this another way, and this is using composition. So we have the same function, and this is going to return 2 times x. But instead of storing that value in the variable y, instead the answer directly is put into print. And so print will get the answer of double times 5, and then it will print that. So you see that it's a distinct way of handling it. All right, so we've talked about quite a lot of things. Let's just take a moment to review these things and check your comprehension of the concept. So here are a couple of questions for you to do. I would recommend that we talk through how this works, and then you should pause the video to go try this for yourself. So what we're going to do is we have some functions over here. I want you to identify the functions. How many are there in each function? Identify key parts, definition, local variables, return statements. Where are the function calls? Where are the local and global variables? And then trace through the flow in the functions. This is a little bit interesting. There's a slight little twist in here that we haven't exactly seen, but I've given you all the pieces to figure it out. So go ahead and try that and see if you can answer these questions, and we'll be back here in a moment. All right, so welcome back. I hope you've had a chance to take a look at this. So the functions, of course, are calc length, calc width, and calc area, all identifiable by their definition right here. Okay, and each function identify the key parts, the definition. All right, we've just identified those. The local variables, and yes, so the local variables in this first function are going to include both its inputs and length. This one similarly will include the inputs, and this one has width. Now, calc area has four input parameters, and we're going to have this be also having variables called horizontal, vertical, and area. So this one has quite a few variables. Now, where are the function calls? All right, so this is the one that's a little bit interesting. Okay, so here's some global variables called side and dimension. So let's just get an idea of what's actually happening here. We're trying to compute the area of something, and we have some sides of some tiles, and we have the dimensions of the tiles. Okay, so what we're going to do is we're going to multiply the side one, right, to get the total length, and then we're going to multiply out the side two to get the total width, and then we're going to multiply the length and the width together in order to get the total area. That's the basic idea, and so we could map out some rectangular tiles to illustrate this problem. Basically, that's what we're doing here. Okay, so where are the function calls? Well, our first function call is right here, calc area. So you might say, well, no, we have functions here. No, it's not, because those are just the definitions. So just because there's a definition does not mean they actually execute. So the flow will read in and learn how to do these definitions. It says, great, all right, I know how to do that. Do some variable assignments, and now I get to print. So print starts, but it's not going to finish yet. So what it's going to do is it's going to do a function call. This is the calc area. So it's sending up these values for side one, side two, and the x and y dimensions to the calc area function. So this one, in fact, gets called first. Now these all get transferred, and we have shadowing going on here because the name of the local variables is the same name as the global counterparts. So horizontal equals calc length of side one in dimension x. Well, that's interesting. This is a function call inside of a function. Can you do that? Yes, you can do that. So this calls then the calc length function, which now is going to send up this information, right? It gets sent into these variables here, and we are going to compute the length. And then it will return length into this, to the point at which it was called, which is right here. And that value that gets sent back, the length, will be stored in horizontal. So this is an example of capturing the value into the variable horizontal. Now, similarly, we're going to have another function call for vertical to calculate the width. Finally, the area is equal to the horizontal times the vertical. So this is multiplying together these two values here in order to get the area, and then we return the area in this line here. So we had the function calls then inside of the calc area. There's a function call here, a function call here, and there's also, well, print is also a function call, and so is the calc area. So we in fact have 4 function calls in this code right here. The local and global variables we've already gone over, and to trace the flow through the function, goes from top to bottom, print opens, we go to calc area and run through this. When we get to the horizontal one, we do the function call to calc length, so that transfers the function control to here. That returns back to horizontal, then we go to vertical, which executes calc width, which brings us through this function back to the vertical variable, which takes up that value. Then we do the area, and then we return area, which goes back to the print statement, which then gets the value returned for area and prints that. And that is the flow through this function, through these functions. So that brings us to some advanced concepts about the functions. And we need to talk about the exact order of how the function execution is carried out. So a function basically causes a detour in the flow of the program of execution. So we've kind of been talking about this even just in the last example. The function arguments are evaluated, the new variable table is created, assigning the argument values to the function parameters. That is, we have a sort of like a mini variable table that's just for that function. Control is passed at the beginning of the function body. Control flows normally within the function body until a return statement is reached. The expression following the keyword return is evaluated. If there's no expression, then of course it's going to assume that it's none and none will be returned. The function's variable table is abandoned. It's deleted, erased, never to be found again. The return value is assigned to be the value of the function call, and the control is returned to the function call site. So these are the steps that are executed in order to actually carry out a function call. Call graphs are a useful way of representing what is happening. So here is a definition of add and greet function. This takes two inputs, x and y. It is equal to x plus y, and now we have a function call to greet user, and we are going to return it. Here we have our greet user function, which prints hi there. Notice that there is no explicit return statement, so that means that this will be an implicit return and that it must return none. Out in main, we have x equals 39 and y equals add and greet. Here we have some expressions that are going to be sent up into the functions. So what we want to do is see what the program does by drawing its call graph. So out in main, we have the variable table x, which contains x and y. So the value of x is 39, and the value of y is equal to 42. We don't know the answer yet, though. So as we're starting this out, we don't know. So we would, as we're filling this graph out, say, well, we don't know what it is. We'll leave it blank. Okay, so to find out, so that's basically what we're trying to do here, is find out what is the value of y. That's the purpose of executing all this code. So when we run this, the call graph has an arrow that's going to be used, and then we're going to draw a box for each space of execution, each scope. And so this scope now is going to be the add and greet, because we're calling the add and greet function right here. Here is add and greet, and that has which variables in it? Well, it has its local copy of x, its local copy of y, and it's also going to acquire the value for it right here. So what we do is we fill in the values as we go. So we sent up 3 and 39, and so those will be the input parameters for the function. So they are assigned to x and y respectively. So here they are being assigned in the variable table. Now the next thing that happens is it is assigned the value of x plus y. So that will use the local values of x and y, which we get off this variable table. So we sum 39 plus 3 to get 42, which is the value of it. Now that is here. Now we get to the greet user, right? So we don't return it yet. We go to the greet user. So that is represented by this line here, because now we're moving out to a new function, which puts us in a new scope. So what happens is we write in the information that's sent. Well, it didn't send anything. Is that fine? Yes, because this one doesn't require any input. So there is no information sent, so the parentheses are empty. Now we go to the greet user, and it says here, it equals print hi there. So it is going to be a variable. And we want to know, well, what is the type? Well, what does the function print return? Print doesn't return anything, okay? Print just displays stuff on the screen, which is represented by this over here. So here, we are calling the function print, and print prints some information, right? But it returns nothing. So none gets sent back. So it gets assigned the value of what is returned by print, which is none. So it equals none, which is why we wrote it equals none on the variable table. Now, what does this function return back? Well, there's no return statement, so it must be returning none. So here we have none, and our flow goes to where? Well, what called it? Well, it was this function call right here. So we go back to this box at the point at which we left off. And now it says return it. Well, what does it equal? Well, we're going to use the it from here, right? Because we notice we also have it from the greet user, but now that variable table is erased forever because that function is ended. So we use the it from this variable table, which is 42. So now we're going to send back the value of 42, and phew, finally, that is going to be assigned to y. And so now we can fill in the variable table and fill in that y is equal to 42. Now that might seem a little bit complicated and convoluted, but it is very good because it does in fact map out all of the different aspects of the call graph, and it really shows what's calling what so that you can really understand what's happening in the program. So these are very useful to do, and if you want to practice with these, that question we had before about calculating the areas is actually an excellent problem to work if you want a little extra practice. So for a function to work properly, its arguments must fulfill certain preconditions. Most important among these are their types. For a function to be useful, its return value must fulfill the host conditions. So that is, we have some types that we need to know for what goes in, some types we need to know for what goes out. So because of that, what we want to do is we want to keep track of the types. Now, an interesting thing about Python is, in fact, it is a dynamic programming language, which means that Python allows you to switch up the type as you go through the program. So you could say x equals 5 and x equals dog and x equals true, all in the same program, and Python wouldn't have a problem with that. However, dynamic typing can be a little bit dangerous, and we really don't want to be doing that inside of functions. We really want to be consistent about what's going to happen. So this is why we have information inside of our functions that we put there for humans to read as we write the functions so we can understand how they work. Now this is called the function signature, and when you write functions, your function should have signatures on them. So here's a definition of a function called quotient, which takes inputs x and y. The signature on this is specifying what the input types are. So it takes 2 integers as input, and the output is going to be an integer. So the precondition is that y is not equal to 0. So of course division by 0 is undefined, which is why we said this. And so this is going to return the quotient of the arguments. Now notice that it's actually doing floor division, which is why the type would be integer. So if it were a regular division, the type would be float. Okay, so a function's signature describes the expected input and output types. The precondition is a Boolean expression or predicate about the function arguments. Now let's turn to capturing the return value, which I've already alluded to when I was talking about catching this orange. So in order to capture the value of something that is returned by a function, you must capture it in a variable or as the input of another function. If you run interactively, the value will appear on the screen, but you cannot use it again, just like when it is printed. So what we need to do is if you need to use it again, you need to store it into something. Okay, so here we have a function that's returning n plus n, and it will in fact show 6 on this screen because it's returning that value, but it's not in the variable. Here we have an example where we have, again, the return double, and we have x equals double times 2. Notice that in this case, whatever double is returning will be stored in the variable called x, and then we can print x. So this is what you want to do in a script, for example. I mean, you can do it interactively, but it's a little bit redundant. Here we have a function returns the value to print. So what we can do here is, you see we have an example of composition. So we can either store the value the double of 2 returns in x and then print x, and in this case, using composition, we skipped storing it in x, and the output a double of 5 will go directly into print. So there are a few points about functions that I just want to reiterate. You can call another function from within a function. Functions can be chained together, just like in math. This is called the composition. Print and return are 2 distinct entities, and you should not confuse those 2 things. All functions return something, but the return is implicit if no explicit return statement is used. All functions do return something. Implicit returns return the value none, which has the type none type. So if you do the type of that function, it will get the type of what it returns, which is none type. So here's a program with 2 functions. Which function prints something, which function returns something, and draw the call graph to illustrate the difference between each. Okay, so let's just take look at what's going to happen here. This one is going to return n plus n, and that is going to return the value. Whereas if we call function b, that just gets shown on the screen. Now, if we ask which of these functions can we use the thing that gets returned, actually the answer is neither one, because you see it's not stored in a variable. So that's always the catch. You want to make sure that you both send that information back and that it's captured in something. Those are the two things you need to do in order to continue to use that information. Python, in fact, has a number of built-in functions already available for you to use. Some familiar Python functions are type and print, which we've already encountered. Type will return the type of an expression to the caller, and print will print the textual representation of an expression to the screen. There are also some others. The print function takes an argument and has the effect of printing it to the screen. We may also want to take the input from the user or from the keyboard and give it to the program. So how could you do that? The input function is the built-in Python function which performs that activity. So if you have input and then you give some prompt, like the prompt should be the question. So if the program stops running, the person needs to know why, and if you didn't prompt them, they wouldn't know to type something. So the prompt is the string that gets printed to let the user know what to enter. So if we have input, what's your name? The user will see what's your name, and then they'll know that the program has stopped and is waiting for them to type their name. So the input function uses this prompt, which is a string, print that to the screen, and then the user can input some information, which will then be returned to the program. So if you want to store that information for later use, just like with any other function, you need to have a variable that will capture it. So here we have name is going to capture whatever the user types because it will be returned by the input function. Then we can use that information to do something else. So here, for example, we're printing back a greeting message to that user. There are, in fact, a number of coercion functions. Now, we've implicitly talked about the coercion functions, but we haven't actually spoken about them per se. So let's just take a moment to do that. So the idea behind the coercion functions is that Python has the ability to try to convert the types of a value from something to something else. So for example, we saw that Python was implicitly coercing some integer values into floats when we were doing regular division. So if we inputted two ints, it converted them into floats and then went about its business to actually compute the answer to the division problem. So you can actually try to do conversions of many different types between any other types. And so some coercions are going to make sense and some are not going to work. So let's just see how that will work. The coercion functions are named for their target type. So a string of something will try to convert it into a string. Int will attempt to make it an integer, float and bool, as you expect. So, sorry, there's this little problem here. We have this box over the top. What do they depend on? So you see, the point is that some of these are going to not make any sense at all, right? So if you try to do int of 3.999, that at least makes sense, but it does something that you might not expect. There's no rounding here, okay? So it's going to convert it into 3. If we have int of hello, that of course makes no sense at all. There's no way to convert hello into an integer because that's a text. So we see in this case with int, it's going to just do chopping. It will take the whole number apart and return that. Boolean of false becomes true. Now this may look really odd, and that's true. Basically, this is because there is this thing in Python that anything that is text will in fact be true, even if that text happens to be false. The word false, right? It's the string representation of false. That will be true. However, if you do Boolean of false, then it will come back as false. So if you do Boolean of my string, just like Boolean of false, it will come back as true because of this abnormality. So we can see that there are some examples that are a bit mysterious, but these are some things that we can understand. So the implicit coercion is when Python attempts to convert something that we did not exactly expect. That means we didn't actually tell Python to make that change. So if you use the function, so you say stir of 5, right? That's explicit coercion because you're explicitly using the function. It's an implicit coercion when Python decides to do that for you. Oh, it's being so helpful, which most of the time it is. But sometimes some unexpected things will happen, right? So for example, let's consider doing 2 plus 2. So print, in fact, can only print text, strings, that is. And so 2 plus 2 is not going to give a string, it's going to give an int. So what will happen is Python will implicitly call the string on the answer 2 plus 2, and then it will print it. So these are, in fact, both representations that are both equal in terms of what Python will actually do. So implicit coercion may seem convenient that it does it so that you don't actually have to write this out, but oftentimes it can cause some problems, and that comes in when we think about overloading. Now, coercion with Booleans, this is going to break out some of those unusual things that may happen when you try to do coercion with Booleans. And this is an example of where coercion may not be as helpful as you think it might sound. So if we have the Booleans, they have associated integers with them. So true can be coerced into 1 and false can be coerced into 0. So overloading of Booleans and mathematical expressions is allowed. So some mathematical operators are overloaded to allow working with Booleans. The Boolean is coerced into its integer equivalent, and then the operation is carried out. So looking at these things in the beginning, you may say, huh, these don't make any sense. What do you mean true plus 2 equals 3, right? Okay, so if you didn't understand this association was happening, you'd have no idea what's going on. But if you realize this is what's happening, it's coercion, then it makes sense, right? So you just substitute 1 for all the trues, and likewise, you could substitute 0 for all the falses. This one causes a division by 0, which is why we get the division by 0 problem that we see here. So Python math functions from a module. This is really useful because we have the capability to bring in additional math functions than the essential set that we've been talking about thus far. So to access pre-existing functions in Python, we can use the import command, and that will allow us to use the code that is written in the external files that are provided by Python. And then we can use the name of the module that has the functions in it that we want to use. So you just do import math. So import is a common word used to bring in outside code, and math is the name of the one that we're mentioning. So the math module allows you to access additional math functions, which includes many of the familiar trigonometric functions, the value of pi, square root, and exponentiation in more detail. You can explore more of these things when we are working on the lab, but they all basically work the same way. To call a function, you need to use the name of the module, a dot, and the name of the function you wish to use. This is referred to as the dot notation. So because the module that we imported was called math, we need to indicate that we're going to use the math code. So let's say we wanted to take base 10 log. So we're going to do math dot and then log 10. So this is the name of a function that somebody else wrote that is inside of the math program that you just imported. And here we provide the argument information. So here we will work with the math functions in the upcoming lab this week. You can compose functions using the math module. So similar to the use of parentheses that we've already seen, Python can return a value from one function and pass it to another. So for example, if we have 5 times 3 plus 1, we would parse 3 plus 1 first and then multiply by 5. So this is an example of composition that we've already seen. Similarly, we can use composition with more complicated expressions. So here is an example of first taking the square root of 4, which of course is 2, and then we're going to take the sine of 2. So this is how we would do that. We would do import math, and then we do math dot sine of math dot square root of 4, which would then return the answer to us. Dynamic typing is this idea that Python can allow the type to be something different throughout the program. A variable has an associated type with it, and the types may be able to be changed by using the coercion functions on them. These same variables may have more than one type in the same program, although it's possible. This should be used with caution because your type could be unexpected, and then you may accidentally run the wrong code because your type is indicating a certain section of code. So knowing the type of your variable at all points in execution of your program is absolutely imperative. So here's just a little example of what that would look like. So suppose we have x equals 5, the type of x is an integer, and now we're going to do a coercion. So this is an explicit coercion to change x into a float. And now if we ask what is the type of x, it will tell you that it is a float. So this is dynamic typing because the variable x has had both the integer type and the float type associated with it all in the same program. So here is a series of print statements that include some expressions. So rewrite the print statements to make any coercion explicit. What will Python return, and will any make any errors? So I would encourage you to pause the video and go ahead and try to work on that and see if you can come up with the answers, and we'll be back. All right, so here what I've done is I've actually printed out for you the answers to each of these questions. Of course, in order to print all of these are going to need the string to do the explicit coercion. And so we're also going to be looking at if there are any coercions in the actual mathematics here. Okay, so in this case, we have integers and floats being converted here, and then they'll be turned into strings and so on. Now here, what we're trying to do is we have an error, right? So in line 1, print string of 2 plus float of 2, you see that we have a coercion to a string right here. And so because we have done that, this becomes a problem. Now one way to fix it is you could change this into concatenation by making the second term also a string, and you wouldn't get the error message, but that's not what was indicated. So you always have to watch your types. You can't convert float to string implicitly, so this also caused a problem. And then we have some examples here of those substitutions that are occurring because of the numeric values of true and false. So then that brings us to our summary slide. We have talked about a major topic today in Python programming. So this is probably the most challenging lecture in the first half of the course. So if you have mastered this, you are well on your way. If you still feel like you have a few questions, you're in good company. This is part of why we have many things for you to work on to get more practice on how the functions work. To summarize what we've discussed, we've talked about functions nuts and bolts, which included the purpose of functions, the syntax for actually defining them, how would you define them, the global and local variables, the concept of return with implicit and explicit returns, and also what the type of what it is they return, so the none versus the none type. And we've also talked about how the flow in programs can be diverted. In the advanced concepts, we've talked about function composition, the call executions, drawing some call graphs, doing specifications and signatures on your functions, and effects of the functions, that is their ability to affect the values in the rest of the program. Finally, we rounded this out with discussing some built-in functions in Python. We revisited print and also type. We've talked about input function. We also talked about the coercion functions and how they can be worked, and I introduced you to the math module. So I hope you've learned a lot about Python today and enjoyed getting a look at how code can be modularized using today's topic of functions in Python. Looking ahead, you should report to your lab section. So this is the recording for week 3. So this will be the first week that we are planning to have in-person options available for those of you who have indicated you wish to do so. At the time of recording, our current plan is to lay out the room so that you'll know who your lab partners are and where you'll be sitting before you actually go to lab. It's absolutely imperative that you know what you're doing when you go to lab, because unlike our usual protocol where it's fine to be milling around the room and greeting your friends, we really need to have the social distancing in effect. So you'll need to know exactly where you need to go. Our TAs have graciously agreed to work with me and working out the rotating schedule so that everybody gets a fair turn to go to the in-class in-person option, and the rest of you will be online with your lab partners unless you've indicated you wish to work asynchronously, in which case I'll be expecting to see you during the office hours or zooming in at the labs or whatnot so that we can just check in and have a quick chat. So that's basically how this will be operating. It's really important that if you have any questions about this, you reach out to your TA for your section, or that you reach out to me for clarification, so that everything runs in an orderly fashion and that we make sure that everyone stays safe during the pandemic outbreak. All right, well, thank you so much, everyone. It is great to chat with you, and I look forward to the opportunity to meet you. All right, we'll be talking soon.